Welcome to Unit 1, Lesson 1. This unit's lesson is What is Matter? It's our first unit of our Chemistry Regions course. Thanks for coming. All right, today we'll learn how to classify matter and draw particle diagrams. We're going to use this in your packet. So first thing I want you to do is open up your packet. That would be your note packet. So it should look just like this. Open up that packet and we'll turn to the first page of notes. You'll see, first of all, a little bit on the packet, you'll see vocabulary that we'll learn throughout the unit objectives, and a nice diagram of basically everything we're going to go over today. So take a look at that and we'll go ahead and start taking notes here. So this, I believe, is page 3 of the packet. We're going to look at what is matter and define that first. Matter is that anything that has mass and volume. So anything that has mass and volume All right. There's different types of matter. One type of matter is something that can't be separated by physical means. It's called a pure substance. So it's the same throughout. Each piece is identical. So no matter how small or large the piece, it's going to have the same composition. And if ever I use words that you're not sure, like composition, this is what stuff is made of. If it's not a pure substance, then it's going to be a mixture. Okay, we'll talk about more details now. Different types of mixtures, different types of pure substances. So let's go down for the start with the pure substance. Pure substances that can't be separated are in their elemental form, so we call them elements. Elements are examples of elements as, let's say something you may have heard of, sodium. Sodium, its chemical symbol we use, its elemental symbol is Na. It comes from the Latin. And sodium is what we call a monatomic element. So it means it's an element that has exactly one molecule, one atom in its elemental form. Another type of element is nitrogen, the most common gas in our atmosphere. Nitrogen's symbol is N2. And because there's 2 atoms in that element, it's called diatomic. All right, let's draw what a particle diagram of, let's say, nitrogen gas would look like. The nitrogen gas would be a diatomic element, so you'll see these 2 atoms connected together, bonded, floating around as a gas throughout the container. And that's what this box represents. All right, let's take a look at another pure substance. This is a pure substance that's also the same throughout, but it could be separated chemically. And so it's a compound. Means it's made of more than one thing. And a compound, another name for that in chemistry is called a molecule. So a molecule contains more than one element. And if elements are bonded, like, for example, NaCl, this also is known as table salt. Or another one of my favorites is octane gas, gasoline that you use in your car. So the octane comes from the 8, C18. This is octane. Now if you take table salt, it's the same throughout. Octane gas, gasoline is the same throughout. I won't talk about like they had additives to gasoline, but just pure octane looks just like that. Another common one that you might have heard of is H2O. I'll assume you know what that is. The particle diagrams for compounds or molecules look like this. So it's just going to be that one molecule. In the case of water, it sort of looks like Mickey Mouse. Didn't specify whether this was a particle diagram of a gas or a liquid. So let's say it's a gas, like water vapor. It just floats around in the particle diagram, but you'll see it's the same throughout, all the same molecule. We talked about mixtures. Mixtures are things that you look throughout and each piece is different. All right. So if there's a part, there's more than one piece in it. In this case, each piece is different. Oops. All right, so get that together. Oh, that didn't help. Each piece is different. I'll try to do better on my handwriting. Each piece is different, and so there's some examples I'll give you, but let's talk about how you break it down. Each piece is different, but if it's the same composition throughout, that means it's called same. We'll use the Greek word for same, which is homogeneous. And a homogeneous mixture is like salt water. Salt water obviously contains salt and water, but because they're mixed together so well, you can't tell the difference. Another one of my favorite things to use an example is iced tea. If you get a really well mixed iced tea, you won't see any particles in there. It looks all the same throughout. When you look at the mixture of them, you might see if these are the salt particles and these are the water molecules, you'll see them mixed evenly throughout. And so they're mixed together as the nice proportion, but that's it. How about things that are different composition of the mixture? Well, we'll use that heterogeneous mixture. And when you think of this, it's not the same throughout, so it's not uniform. That's the key word. Where homogeneuses are, these are not. What else can we say? A chocolate chip cookie. Italian dressing. This one always makes me hungry. We find that a lot of food are homogeneous mixtures. Concrete. Those are our examples of heterogeneous mixtures. What would it look like as a particle diagram? Well, you'd have a single particle here, maybe a different particle here, a different larger molecule over here. Just mix all throughout. Nothing looks the same, and certainly not uniform. All right, those are our mixtures. Let's take a look at the next page. So we'll practice what we learned. First thing is, which particle is, let me zoom in here, which particle represents a mixture? Well, this one is two different elements, it looks like bonded together. And so this one is not a mixture, it's a pure substance. What type of pure substance? You could tell that these are not the same elements because they're different colors. So this would be a compound or a molecule. Okay, so it's not this one. And this one looks the same throughout, same number of atoms, same type of atoms. This is definitely an element, so not this one. We're looking again for a mixture. Here we have two different compounds together, and so this will be a mixture. This is a diatomic element, definitely not a mixture. Which represents a pure substance? This looks good. This is what we call a molecule. This looks good. This is an element. This is a mixture of a compound and an element, so it's a mixture. This is a diatomic element, and so option 1, 3, and 4 are all pure substances. Which of the following represents a mixture of one compound and one element? All right, take a look at this. First one, we have big old monster molecules, some smaller molecules around it. We need a compound, so this definitely is a compound. Unfortunately, water is a compound too, so this does not contain an element and compound. Here is an element, here is a compound, So it contains both. That's good. Here's an element. Here's an element. Mixture of two elements. Could be like salt water. So this is a compound, but in its entirety, but it does not contain one compound and one element. It's just basically two different elements. Oh, sorry, I just said it's not, and I circled it. Okay, which particle represents a diatomic element? Diatomic element would be, hopefully you recognize it, is this one. All right, let's move on to some more practice ones. And understanding properties of matter. All right, physical properties are constants about the substance, so you can use our senses to observe them. You don't need to do any special chemical stuff to them. So extensive properties are properties that never, well, I should say, they depend on how much material you're dealing with. So if you look at how much heat a rock left in the sun will give off at night, well, it depends on how much of it is that you have. So heat that it contains is an example of an extensive property. How much energy does a magnet can produce? Depends on how big your magnet is. So energy. How heavy is it? Yeah, that depends on its mass. And so, this is mass. So those are all things that are extensive properties. Depends on how much, to the extent you have of the matter. Intensive properties are things that are part and make up the identity of the matter, and they never change. For example, melting point. Melting point doesn't change whether you have an ounce of something or a pound of something. All right. Another one is boiling point. Other one's color. Its color doesn't matter if it's a small amount or a large amount. Its density. Its hardness never changes whether it's a small amount or a large amount. So a small diamond is just as hard as and salt. Solubility is a large diamond. Solubility doesn't matter if you do a little bit of salt or a lot of salt, it still dissolves in water. How about its chemical properties? It's the last of the properties. There's extensive, intensive, and chemical properties. They depend on how the substance, matter, react with other substances. Example, there's these group 1 elements. It's the first vertical column in the periodic table. They all react with water. Oops. There we go. I'm still getting the hang of this. They still react with water. All right, let's do your best to identify these. The mass of a copper wire. Identify this as extensive, chemical, or intensive property. All right, because it says mass, keyword, the mass is an extensive property. Oh, there we go. The boiling point of ethyl alcohol. Boiling points never change within a substance. It's intensive. It's embedded within the substance. Baking soda reacts, it's a keyword, with vinegar to make carbon dioxide gas. So that's definitely a chemical reaction because there's or chemical property. Density, that doesn't change no matter how much you have it, so it's intensive. The solubility of a sodium chloride, that's an intensive property. It never changes based on the size. All right. And I think that concludes our notes for today. You will see that you can work on the homework on practice packets page 2 to 4. So open up that in your practice packet. And if you open up your practice packet, you'll see the very first task on page 2 is a classification of matter. So I'm not going to do this on the video. These are the things I want you to work on your own and figure out which each of these are. I might do the first one or two with you. I wish you could tell me which one was the hardest. Let's take a look at number 10 just because that looks really delicious. A bowl of chicken soup. Is there an element called chicken? No. Chicken soup is not an element. Is it a compound? Could be. It's a molecule, right? Well, chicken made up of protein, which are molecules, but it's made up of all the different things, hence it's a mixture. And then, is a chicken soup the same threat? No, because you could get really lucky and get a lot of chicken and yummy vegetables, or you could get unlucky and get just a bunch of broth. So you want to make sure you recognize this as heterogeneous. It's throughout. So I'm going to write heterogeneous, or heterogeneous for short, mixture. Right, and so you go through these. You could also just write hetero there, I guess, and identify those. What's the next part of your homework? One classifying, more than one. So you do all that you can think of. Cannot be decomposed by chemical means. I'm hoping you'll remember that this is an element, an only element, right? But if there's more things that it could be, oh, it's an element, but also a pure substance. And also matter, if you were going to get really sticky on the matter. But element is what I'm looking for here. All right, that concludes the lesson. Thanks.